Hello everyone, welcome back to the class. Let me just check if I'm online. Okay, so once again in today's class we are going to learn few concepts from motion in a plane. So last class we were learning about vectors and what is the need for vectors and what are the types of vectors, right? So in today's class what we are going to see is that how do we add vectors, right? You cannot add a vector algebraically, right? Because it has a magnitude and a direction. So in today's class, we're going to see how to add vectors and what are the different vector laws we have. Right, that's going to be the focus of today's class. And once again, before I begin, my name is Mohana. I'm a physics educator here at Unacademy, and this is my Telegram channel link. You can follow me here. Any updates regarding any course will be shared, right? My community link also will be shared here, so you can follow me in the Telegram channel. And as well as this is an Unacademy ICSE and ISC board common Telegram channel, so you can follow this channel as well. All right, and okay, all right, one more second. All right. Okay, so just like how we have free classes on the YouTube channel, we also have free classes on the Unacademy platform. These classes are absolutely free. You can take any of your favorite educators' classes and you can engage with the educators via the pool feature, right? And these classes are also live classes. So any doubts you have through chat, you can get your doubts cleared then and there. All right. Now, the link to the upcoming special classes, right, is given in the description box. So you can just click on the link for class 11, go to the link will take you to the Unacademy page, right? Just give it for the upcoming classes. You can just give me notify me, and before the class goes live you would be notified. All right, now the tomorrow we have a special class. So this is part 2 of the basic mathematics for physics. So tomorrow's class we will mainly concentrate on basic differentiation. What is the basic differentiation and integration needed for the physics, okay, and basic formulas that we need to know in integration and differentiation for physics, okay. With that we will try to solve few numericals. Now since we are doing vectors on the YouTube channel, the part 1 of the application series is already over, right? And here we will learn more of the definitions, how to add vectors and everything we will learn here, right? But on 29th June, this class will happen again on the Unacademy platform, and in this class again we will be learning about the practical applications of vectors. All right, okay. Now, with that note, in case if you're interested in the Plus subscription, these are the benefits. One is you can learn from the comfort of your home, and whenever you're taking a Plus subscription with Unacademy, you are actually taking 4 subjects. You're taking physics, chemistry, math and biology. So if you're taking Plus subscription, it's just not for one subject. You're getting 4 subjects, all right? And you will get unlimited access to all the courses, that is all the 4 subjects, right? And you will be learning from the top educators, because anyway all the educators on the Unacademy platforms are really good, right? And as well as these Plus courses has an advantage, that is every 4th class is a doubt class. So you have a regular doubt clearing session. So let's say the course begins today. So the first 3 classes, first 3 days, right? First 3 classes will be like a normal course. You can actually get your doubts cleared then and there. But in case later on, if you still have some misconception about any topic, or in case let's say one of the days you were not able to attend live, okay, and you had to see the class recordings and you have some doubts, then you can ask those doubts in this doubt clearing session. So every 4th session is a doubt clearing session, okay. And in your Plus subscription, we will cover your entire syllabus. There are many practice tests available. Other than this, there is also live test series that happens every other week. So in the live test series, you can attend the test, right? Right after your test is over, there would be an analysis session where the educator will step by step solve the questions that was given. Okay, so if you have any misconception about any of the questions, you can get that cleared then and there. Okay, or if you want to know how to solve a question much more easily, you can learn that as well. Okay, there are some upcoming batches. This details I'll give you as well. Now, with the Unacademy, if you see, right, the longer duration you take a course, the price per course goes down. Right, so price per month goes down. So instead of taking a 3 months, so when you're taking a course, you're getting 4 subjects. So instead of taking 3 months, let's say you're taking a 2-year subscription, then you're only paying 1,198 rupees per month. Okay, on top of it, if you're using my educator code MTIS10, then you'll be getting a 10% discount on the same. Right, so now you will get the course per month. You're getting 4 subjects just at 1,078 rupees per month. Okay, and at the same time, if you're in class 11, there is an added advantage. So you only have to pay for 1 year. Okay, you just have to pay for 1 year. Okay, or 1 year of this fee, right? And you will be getting class 12 subscription absolutely free. So that's the advantage of taking your course plus course with Unacademy at class 11. So you just pay for 1 year, you are getting the course worth for 2 years. Alright, so here again, you get 4 subjects: math, physics, chemistry and biology. For physics, we meet every Tuesday, Thursday, Saturday between 5:15 to 6:50 p.m. So this is an ongoing class now, ongoing batch now. We started only on June 8th. In case if you have missed few classes, previous classes, don't worry, class recordings are always there. You can watch the class recordings, and during the doubt sessions, you can get your doubts cleared. Okay, and the mode of delivery is going to be is actually in English. Okay, and here again over here, if you can use my code MTIS10 to get a 10% discount on the same. So whenever you're taking a plus subscription, you are getting a minimum of 10 classes for each subject. So in a month, you're getting minimum 40. Each class is 1 hour. So you're getting a minimum of 40 hours per month. Other than this, there would be test series, practice test available. Also there would be like, live test series available. All of these, excluding all of these, a minimum of 40 classes you will have in a month. Okay, so the price that you're paying per class goes down drastically. You might be paying within only 20 to 30 rupees per class. Alright, so that is about the course. And now let's start with the motion in a plane. So last class we had started with what is a motion in a plane. So this basically we started with what motion in a plane. So when we actually discussed the idea that when you have to take in, when you're talking about motion in a plane, you're taking 2 coordinates, right? You can no longer use just 1 coordinate system. You're using 2 or 3 coordinate systems, right? 2 coordinate system in case if it is a motion in a plane. If it's in motion in a space, then you have 3 coordinates. When you go for a motion in 2 dimension or 3 dimension, then a quantity called as vector is needed, right? Because that would help you give the magnitude and the direction. So that leads us to the exact definition between what is a scalar quantity and what is a vector quantity. So we have done this point in the last class, so I'm going to quickly skip this. But if you know if you still have any misconception about what is a scalar, what is a vector quantity, you can let me know in the chat box and I'll give you a brief introduction once again. Alright. Now, a scalar quantity has only magnitude, right? A vector quantity has both magnitude and direction. Alright, so if you know, you can actually give me the examples we have discussed in the last class. For example, mass is a scalar quantity and a vector quantity, velocity is a vector quantity. Okay, so if you know more examples, you can share them in the chat box as well. Okay, now from here we saw what are the difference between scalars and scalar quantities and vector quantity. Okay, now when you're talking about a vector, right, the length of the vector represents what is the magnitude. Okay, and the arrowhead points towards the direction. So this end is the tail and this end is the terminal. Okay, or we call this as the head. Okay, the tail point is also called as the initial point. So this is how you represent a vector. Now there are 2 different types of vector. One is a position vector, another is a displacement vector. Let's say there is an object that is somewhere over here. Okay, and from the origin axis, this is x-axis, y-axis, and this is the origin axis, right? From the origin, right, if you are able to find, okay, from the origin, I'm gonna say, okay, this is the length of this is the distance, okay, this gives you the magnitude in a straight line path of the position of this particular particle. Okay, let's say a B is at rest over here. B is saying at rest, okay, it's not moving anywhere, it's at just in one place. Now from the origin where it was to where it has gone, right, from this point, from an origin point, if I just draw a line, okay, it's at this distance from here, right, this gives you the position. Okay, now let's say the B was initially at this position over here, and after some times it moved to this position. Okay, now the distance from here to here, from the first initial to the final position, this vector is called as a displacement vector. This is a position vector, this is a displacement vector. Okay, it's a quick recap on that. Now there are various types of vectors. Okay, polar vectors are extremely simple. Okay, the position vector that you're seeing is a polar vector. Your velocity, displacement, all of these are polar vectors. Okay, but when you're talking about an axial vector, okay, then your angular velocity, torque, okay, force is a polar vector, but torque is a axial vector. Okay, velocity is a polar vector, but angular velocity or angular momentum, okay, is a axial vector. So when you're talking about axial, let's say like there is a rotational effect involved. Okay, now these are the two types of vectors. One is polar vector, another is axial vector. All right, that's the very simple definition between these two. Still, if you have any doubt, please ask me in the chat box. Now, how do we define? Okay, the definition in some definitions in vector algebra. One is, if you have two vectors which has the equal magnitude and if they are in the same direction, then we call them as equal vectors. If they have the same magnitude but they're going in different directions. For example, think of this as a lane. For example, think of this as a lane, okay, and this is one way and this is another way, right? Like your roads basically, right? Here, let's say there is a car going at 40 meters per second. And let's say there is a car over here again going in 40 meters per second. Here, the magnitude of the magnitude of the vector is same, but direction is different. Okay, that's again your that would be your then this vector you can say is actually the negative of a vector. Why? This vector A vector is in this direction, but this B vector over here you can give it as A vector magnitude wise, but it's in the opposite direction. So you can call this as minus A vector. Okay, now whenever you take the length or the magnitude of a vector, okay, whenever you take a modulus of a vector, it gives you the magnitude of the vector. Okay, so let's say 40 meters per second due east. Okay, this is a vector. Now if you take modulus of this particular vector, you will only get 40 meters per second. Now this gives you the magnitude. So magnitude of a vector is a modulus of a vector always gives you magnitude of a vector. Okay, now my question to you, if you know the answer, otherwise I'll tell you after some time, is modulus of a vector, because we are talking only of the magnitude, right? Right? Is it a scalar or a vector quantity? Because let's say this is a vector, this means a car is going at 40 meters per second, right? Now when you take modulus of a vector, it just gives you what is the length of the vector, or it just tells you what is the magnitude. We're not worried about the direction, it gives you the length or the magnitude. So will it be a vector quantity or will it be a scalar quantity? So modulus of a vector, when you're talking about modulus of a vector, it is always, modulus of a vector is always a scalar quantity. Okay, now unit vector, okay, unit vector has a magnitude of 1 and the unit vector is in the direction of the is in the direction of the vector itself. Okay, for example, let's say this particular vector over here is again 40 meters per second. Okay, or let's say for easier calculation, let's say this is around 4 meters per second. Okay, now if I can actually take this vector and say, okay, this vector consists of 4 vectors, okay, each of length 1 meter per second. Each one of this is a unit vector. See, the direction is in the direction of the 4 meter per second only. Okay, this is a unit vector. Alright, then you also have a fixed vector. These are, in case of a position vector, right, it will have an initial point, right? These vectors are called fixed or localized vectors. In case the vector does not have a fixed starting point, then we call it as a free or a non-localized vector. We also have collinear vector. Collinear vector is of 2 types. One is parallel or like vectors. Another one is anti-parallel or unlike vectors. When you're talking about parallel vectors, the vectors, they might be going in the same direction. Okay, or it could be more like one is going over here, one is going over here. So theta over here is actually 0 degrees. When you're talking about anti-parallel vectors, this is A vector, and let's say give it a name. This is again A vector and this is B vector. When you're talking about anti-parallel, let's say B vector is in this direction, okay, A vector will be in this direction. So if you see, the magnitude are same, but the direction is different. Let's say A vector is going in this direction, then B vector will be going in this direction, this being the common original point. Okay, so theta over here, if you take, is around 180 degrees, right, in both cases. So collinear vector consists of 2 points: parallel vector or like vector, anti-parallel vector or unlike vector. Okay, next comes your coplanar vector. If the vectors exist in the same plane, okay, either they are in the xy plane or yz plane or zx plane, in any one of the plane, okay, for example, you have the x, y and z, right, components over here, right? So if you have a vector, if you have 2 vectors either in this plane, okay, or if you have a vector let's say in this plane, yz plane, or if you have a vector, or if you have 2 vectors in this plane, okay, then we can say that these vectors are coplanar vectors. Okay, so for example, let's say there is okay, let's say there is a B, okay, which is actually going in this direction in a zigzag path. Each point you need 2 arc points, right, x and z, to represent where its position is. Let's say there is another B and it is going somewhere over here like this. So at each point, this is its initial position, this is its final position. At each point, to represent where it is, we need 2 points, x and z. Now if you see, both the vectors are in the same plane, then we can say it is a coplanar vector. Okay, next is co-initial vector. Very simple. When we learnt about representation of a vector, right, we saw that this end over here is a is called as initial point, or it is called as a tail, correct? If you have vectors starting from here, let's say this is A vector, let this be B vector, let's say there is another vector, this is C, let's say there is another vector D, right? All of them have the same common tail point or their same initial point. Then we call these vectors as co-initial vectors. Okay, I gave you the example of the same last class. Let's say there is a marble here and 4 of you are hitting the marble and you want to see who can hit the marble over here, right? So you're giving a particular force, or you're displacing, there is a displacement for this marble, right? Okay, now as you hit, let's say there are around 4 marbles over here. As you hit, okay, all 4 of them were in the same starting point. As you hit, okay, one goes this way, one goes this way, one goes this way, one goes another way. They all had the same starting point, they all went to different positions. Okay, then you can say this is a coplanar vector. Next is a co-initial vector. Okay, next, this is called a coplanar vector, initial vector. Co-terminal is very simple. Think of a car starting somewhere, okay, starting somewhere. Akshay, yes, Akshay, they are all at the same position. They are all at the same point, but they are acting at different directions. Okay, so for example, let's say there is only one stone over here. Okay, you are, let's say you are applying two different kinds of forces to it. Let's say you are here and you are throwing you are applying a force to it. Because of that, let's say this force is in this particular stone or the marble goes in this direction. Let's say your friend is also here, he's trying to hit the marble, and let's say he actually hits it from this direction, and let's say this is the force he is imparting on it. Now, we saw what is a composition of forces, right? We actually saw what was, how do we resolve a force? We just saw a small concept in the last class. Today we will see that in depth, okay? Now there are two vectors acting on it. The resultant will be in a different direction, but there are two vectors acting on the same point, right? Now, if you see, now this is an example of a co-initial vector. Okay, next is a co-terminal vector. Okay, now if all of, let's say there is a car from some point coming and reaching a parking lot, another car coming and reaching a parking lot, another car coming and reaching a parking lot, right? Now, all of the three are reaching at one point. They started elsewhere, but their final point where they are reaching is same. Then you can say this is a coterminous vector. Okay, these are three different vectors. Let's say but they are all reaching at the same point. If the direction where it's finally ending up is same, then we can say it's coterminal vector. So these we have quickly seen about all the definitions of vectors once more. Now let's see how do we add, or let's learn what is composition of vectors. Okay. Now the result of two or more vectors is that single vector which produce the same effect, okay, as the individual vector would produce. Okay. The process of adding two or more vectors is actually called composition of vector. Alright. This is very simple. For example, as I told you, let's say there is a marble. You are actually hitting this particular marble with another marble. So this marble, let's say it gets a speed in this direction. But Akshay, yes Akshay, like everyone coming towards the same place in case of a vector. Okay, when you're talking about vector, are you talking about displacement or velocity? Think of a vector. Then yes, you can take that as a coterminous vector. Okay, and another one in this case is, let's say you are giving it this force. Now, let's say your friend also hits it, but let's say both of you are trying to hit this marble. You want to hit this marble and make it move. Okay, now you hit it from a different direction, let's say from here, and the force you gave, it went in this direction. Let's say your friend also hit it, but he hits it, but both of you land the shot. Okay, so now this particular marble gets two different forces. Okay, this particular marble is getting two different kind of forces. Right, now if you see the result of this, what will be the result? What will be the final effect? In which direction will this move? Because one force, this is of a different magnitude. Let's say this is A vector, this is B vector. This is of a different, this velocity or whatever force you are applied to for it to get displaced. This vector, this magnitude and direction is different. Here the magnitude, okay, or direction is different in this case. Okay, now what will be the final way? In which way will this actually move? Alright. Now you can understand this by learning about composition of vectors. Okay. Now the final resultant way in which this marble will move is basically what we call as the resultant of two or more vector. Now that will be a single vector which will actually produce, for example, the result of how this would move. Let's say it will move, this one will move in this direction. Let's say this marble is finally moving in this direction. You hit it in this way, your friend hit it in this way. But this marble is going in this direction. Let's call that as the resultant effect. Now, this resultant vector, okay, is the resultant of, this is the resultant of two vectors. Because of the addition of these two vectors, because of this force that was applied and this force that was applied, this started moving in this direction. Okay, now the resultant of two or more vector, that is this vector, is that single vector which produced the same effect as an individual vector together would produce. Whatever. Alright. Guys, just one more second. Okay. Alright, okay, the final marble will somewhere over here. This was its initial position. Now this was the marble's initial position. Okay. Now now this is the final position. Now the force that you apply to displace it from here to here, then from here to here, that you can give it as one single vector. Okay, that is, initially it was in this position, now finally it is in this position. Now whatever the effect these two produced, right, whatever the effect these two vectors produced, it is being now this resultant is giving the if you add these two effects, what is the final effect? This is the initial position of the marble, this is the final position of the marble. Now this combined effect is given by this particular vector over here, which we call it as a resultant vector. Okay, which is a combination of, which is the combined effect of both A vector and B vector. Okay, clear? This basically gives you your triangular law of vector addition. Alright. So again, if you have any doubts with triangular laws of vector addition, just ask me in the chat box. Okay. Now, this vector that you're seeing, this you can add only up to two vectors. Remember, a triangle has three sides, right? So when you're talking about triangular laws of vector addition, you can add only up to two vectors. Okay. Now, what would be parallelogram law of vector addition? Okay, just think of the shape of a parallelogram, right? It has this is the shape of a parallelogram, right? Let's say this is A, B, or PQRST, right? Because we have been using A, B for vectors. So let's just use PQRS, right? This is the sides of the parallelogram. It has four sides. Okay, and now other than this, it also has a diagonal in between. Okay, it also has a diagonal in between. Now, let's say, same case as earlier. Okay, there is one vector which is actually going in this direction, which is actually A vector. Okay. Now there is another vector, let's say that vector is again going in this direction, which is basically B vector. Now if you want to see what will be the combined effect of these two, okay, take the same example as what you did earlier, right? Let's say initially a marble was here, right? You actually gave it, let's say initially a marble was somewhere over here, you gave it a force in this X direction, right? So this marble gets displaced over here. This is A vector, right? So this marble, whatever was here, now finally initial position was this, now the final position after applying this force is over here. Okay, now from here you are giving this, you are giving one more again you are hitting this marble, right? First you hit this marble, it has gone here. Now let's say you are applying this, let's take this as north, south, east, west, right? Let's take four directions, right? North, south, east, west. First you applied a force in the east direction. This was the starting point, east. It went this side. Now you are applying a force actually in the northeast direction, northeast, in between this, right? That's your B vector over here. Okay. Now from here, if you apply a force, where will it go? This particular vector will actually end up landing somewhere over here. This is the force. Now the final direction. Now the final, now where is the marble? It reached here. From here, when you applied a force, now the marble would be somewhere around here, right? So this was the initial position. Okay. And this is the final position. Now how would we find the resultant? We will make use of the parallelogram law of vectors in this case. Okay. Now, okay, so this basically we did for triangular laws, right? Now let's say you gave another direction. This is, I'll tell you how we are getting this. Okay. Now let's say the initial, let's take these two vectors, right? Let's take them as two sides of a parallelogram. Let's say this is one side of a parallelogram, right? That is PQ, right? Right? This is actually a vector. Okay. There's another side which is, again, let's say B vector is along, one more second. Okay, just a second. All right. Right, let's say B vector is along this direction, along PS. Okay, this is basically B vector. There are two different forces given to it. Okay, there are basically two different forces given to this. All right, let's say in this case, okay, in this case, if you want to know for the marble, okay, which is somewhere over here, there is the marble which is somewhere over here. Okay, let's say you also hit and your friend also hits. Simultaneously, two different forces acts on this particular marble. Okay, now what will be the resultant effect it is seeing? Okay, that you can actually give by taking the parallelogram laws. Okay, now if the resultant of this, right, of this effect will be given by the diagonal of this vector, of this parallelogram. See, look at the direction of the diagonal is in this direction. Okay, so the resultant, okay, will be given by this. Let's say this is R, right? The resultant will be given by this. So if you see over here, you can actually extend the parallelogram, right? You can say, okay, this goes in, this parallelogram goes up to here, and let's say this one goes up to here, right? So the resultant would be in this direction. Okay, this resultant is A vector plus B vector. All right. Now, if you see, in case of triangular laws, okay, you can say the vector, you are hitting the marble from here to here and then from here to here. Okay, let's say from here it has reached the final position over here. You can say the same here, or you can say the marble was given two different velocities at the same time. When you're hitting it with a force, you're displacing it, right? So it will travel a particular distance with time. So it's gaining a velocity. Okay, so you are applying a velocity in this direction and a velocity in this direction. Now the final velocity will be along this direction. So this is according to parallelogram law of vector addition. Again, using parallelogram law of vector addition, you can add only up to two vectors. Okay, so this was the initial direction and this is the final, this was the initial position, and you can say this one over here is the final position of the marble. Alright, so this gives you the resultant. Okay, in parallelogram law of vector addition, if you see, okay, here in triangular law, right, you started A vector, okay, you started the A vector, right? In the terminal point of the A vector, you started the B vector, okay? But in parallelogram law of vectors, there are two vectors here, both has the same starting point, meaning in parallelogram law of vectors, they are both co-initial vectors. Right, they're both starting at the same point over here. This is the initial point, right? The tail end is same. So this is an example of a initial vector. All right. Once again, if you have any doubts, you can ask me in the chat box. Now, the next one is basically a polygonal law of vector addition. Right. In polygonal law of vector addition, let's see if you want to add more than two vectors, because you may not just have a condition where you're just taking one vector, or when you're just adding two vectors, right? There is a possibility you might be adding more than two vectors, right? Excuse me just a second. So in such a case, what you can do is we can make use of polygonal law of vector addition. Okay, let's say one vector is going in this direction. This is A vector, Okay, this is one direction, right? This has a particular magnitude and the direction is over here. Let's say there is another vector. This is again, let's say this is going in this direction. It has different magnitude, okay, and it's going in a different direction. Okay, let's say there is one more vector. Let's see, like, you know, let's say this is going in a different direction altogether and it has a different magnitude as well, right? Other than this, let's say there is one more vector again. This, let's say that is D vector. Okay, now if there is like 4 different vectors acting, right, what will be the result of all 4 of these vectors? What will be the effect of adding all these 4 vectors? Okay, that for this right now you cannot use parallelogram or triangular laws of vector addition. We are actually making use of the polygonal law of vector addition. Okay, polygon means a geometrical shape which has many number of sides, right? Okay, so here let's start with this polygon. Let's start with this A vector over here, right? So the A vector over here, okay, now the A vector over here, so if you see, let's say it goes in this direction. This is A vector. Now again, from the end of this particular A vector, we are going to start this B vector. Alright, so B vector over here, it starts from the tail of the A vector, right? This is basically B vector. Okay, now from the start of this B vector, right, from this end over here, you will actually add from this end the head, the head of this, or the terminal point. You actually start the head of this vector. You start the tail of the next vector, which is actually C vector. Okay. Finally, you have one more vector, which is basically your D vector, which starts on the head of your C vector and it goes in this direction. This is basically your D vector. Right? Now, what will be the result of all of these vectors? Right? That will be the resultant vector, right? That will start from the initial point. This is your initial point, right? That this vector will start from your initial point. This is your initial point and it will end in your final point. This place D vector is the final point, right? Now this is actually your resultant vector. In this case, the resultant vector will be equal to A vector plus B vector, right? Plus C vector plus D vector. All of these effects, whatever these 4 vectors acting on an object would produce an effect, okay, that will be produced by this resultant vector. So for example, let's say an object is over here, okay, and at this time, let's say different velocities acts on it. Let's say first the velocity it gains is so much and it moves from here to here. Again, there is a different velocity with a different direction acting, right? Let's say it goes from here to here. Then let's say from here again it moves up to this point. From this point again, let's say the velocity and the direction applied is different. From here it comes up to this point. Okay. Now, think of it as a bee starting from a point, right? It moves till a particular point. Okay. Or you throwing a ball from one direction to another thing from here to here, again from here to here, again from here to here. Okay, now what is the final location? This point. This is where the object initially started. This is its final location. Now the combined effect of all these vectors will be given by this particular R vector. Alright, so these are the 3 laws of vector addition. Okay, so triangular laws and parallelogram laws, you can add only up to 2 vectors. But if you're using a polygonal law of vector addition, you can add more than 2 vectors. Okay. Now, if you see before we go ahead, there is one more thing. Okay. There is one more vector that we still haven't seen. That is basically your. Okay. That's basically a 0 vector. Let's say a vector, okay, a vector that has a magnitude, okay. A 0 vector is also called as a null vector. Okay. Now, this 0 null vector, this actually has a 0 magnitude and any random direction, or you can say an arbitrary arbitrary direction. A vector which has a zero magnitude and arbitrary direction, then this is actually called as a zero vector. How do we call it? When do this zero vector need for the zero vector arise? Let's say we have a vector which is equal to b vector. Okay, then what will be the effect of a vector minus b vector? What will be its effect? This is one condition where a need for the zero vector can arise. Okay, all right. Whatever the result is, okay, it cannot be a scalar, okay, but it has to be a null vector because you're subtracting two vectors, right? It cannot be a scalar, but it will be a null vector, okay, meaning it will have a zero, the magnitude will be 0 and the direction will be any random direction, okay. So it's basically a vanishing vector. Okay, now some of the properties of these vanishing vector over here, all right, that is or null vector over here. If you add a zero vector with a vector, you will still get this particular vector. Okay, now in case if you multiply a real number, for example, let's say you're multiplying a real number a with a zero vector. Okay, if you do that, again you will get it as zero vector only. Okay, now with the vector, if you multiply a vector, okay, with 0, then what you get will not be 0, a scalar quantity, but you will be getting a zero vector which has a zero magnitude, where magnitude is 0, but it can take any arbitrary direction. Okay, now what are the examples of a zero vector, right? We have introduced what is a zero vector. We have seen what are the properties associated with it. What are the examples? Okay. Whenever you're talking about a position vector, we talk about two different directions, right? Let's say on an xy plane, right? This is the initial place, and let's say some object is lying at the point P. Now, from here to here, you draw a line and you say this one is actually a position vector. Right, this is actually a position vector. From the initial point, it shows how much it has got displaced to this point over here. Okay, this gives you the position vector. Now, the position vector, okay, lying at that origin over here. Now, this is not starting from 0, but this point, initial point that it had, is actually called as a zero vector. Okay, now if you're taking a velocity vector of a stationary object means the object is at rest, right? But if you're taking for a stationary object a velocity vector, then its magnitude is actually 0. Direction, it can take any arbitrary direction. So in that case, a velocity vector is a zero vector. Okay, and if you have an object that is moving with uniform velocity, when an object moves with uniform velocity, its acceleration becomes 0, right? Now the acceleration vector becomes a zero vector. In that case, when you say acceleration is 0, it doesn't mean magnitude, it's a scalar quantity. Here, instead of using a scalar quantity, you can say acceleration is a zero vector or a null vector. Alright, so these are some properties and need for these vectors. Alright, now let's say you have also two more rules about the vectors. Okay, vector addition, when you're looking at vector addition, okay, this vector addition is commutative. Addition is actually commutative. What does it mean? Okay, this means, let's say you have a vector plus b vector. Okay, this a vector plus b vector will be equal to b vector plus a vector. This should be same. Very simple. You can understand it using parallelogram law of vectors. Okay, let's say there are two vectors, which, let's say this is O, P, let's say somewhere, that's almost a parallelogram, right? S, okay, and Q. So OP, this is given by A vector, and OQ, right? The OQ, let's say this is given by B vector. Now the resultant of these two will be given by what? Right? This will be OS will give you A vector plus B vector, right? So here, if you see, this A vector plus B vector is actually equal to what? This A vector, if you're looking at a parallelogram, A vector plus B vector, this is actually equal to the side OS. Right, this is actually equal to the side OS. Right, you can actually also say that OP vector plus OQ vector is equal to OS vector. Right, instead of OP and OQ, we have substituted A and B. Now, okay, now over here what do we see? This OP, right, this side OP is equal to the side QS. Right, this side over here is equal to the side this side, and this side over here is equal to this side. All right, so these two, this side is equal to this side and this side is equal to this side over here. Okay, and if you see, this OP is also parallel to QS. This OP is also parallel to the side QS. Okay, so from here we can say this side OP, right, is basically equal to the side QS. So the side QS will actually again be an A vector. So from here I can say this side is also equal to A vector. Okay, this will be equal to the magnitude of the same way as this vector over here, right? So this will again be equal to A vector. Okay, now if you are using triangular law of vector addition again, okay, you can see that, okay, triangular law of vector addition means from the starting point you have B vector, from its tail again another vector is starting A vector. B vector plus A vector, it's again equal to AB vector. From using triangular law, what do we see? We see this B vector and A vector. So this is O, Q, and this is the resultant. Okay, and from the initial, where is the resultant over here? This is equal to AB vector again. Right? So from here we can actually see your B vector plus A vector, okay, is equal to the side OS vector again. So over here you have two equations. This is 1 and 2. If you equate these two, what do you see? A vector plus B vector is equal to B vector plus A vector. So vector addition is commutative. Alright. Similarly, vector addition is also associative. Similar to this, we can also say vector addition is associative, meaning if you are adding 3 vectors, okay, or let's say if you are adding multiple vectors, okay, then of 3 vectors, then you can say A vector plus B vector. If you add two vectors and then the sum of these two, if you are adding with the third vector, whatever effect this is producing, okay, it will be the same as, okay, first adding B vector and C vector, and the result of this, if you add it with A vector, these two would again still produce the same effect. So vector law is commutative as well as vector law is also associative, right? So when you're looking at parallelogram law of vectors, right, you can actually shift the vectors sometime. So instead of doing this and finding a resultant over here, you can just shift this vector over here. You will still get the same answer. Okay, let's say this is A vector. Okay, this B vector that is over here, since the magnitude of this side is equal to the magnitude of this side, we can actually move this particular B vector from the side PS, okay, from here to this. So this is P, Q and R. Right, B vector can be moved over here. Why? PS is parallel to QR, okay, from here, and also we are seeing PS is equal to QR. These two sides are equal and they are also parallel to each other. So if this is 5, let's say there is this magnitude represents a, if you see these two sides are also in a parallelogram is equal, right, and these two sides of a parallelogram are equal. So here if this is 5 Newton, this is also 5 Newton. Okay, so you can just shift the vector, and now again according to Parallelogram only. Now as you shift the vector, what has happened? Now you can add using the triangular laws of addition, and this will be the resultant vector, which is again A vector plus B vector, producing the same result as previous case. Alright, so these are the 3 laws of vector addition. Okay, and we have also seen that vector laws are commutative as well as associative. Okay, now before we end the class, let's see a real life example of, we have done this in the Unacademy classes, right? On the Unacademy classes, on the special classes, we have done some of the examples of this. Okay, but I'll do one example. So let's say there is a sling. Okay, now this particular sling will actually have a rubber band, right? This, let's say you have a sling, and you can actually place, let's say you placed a stone over here. Let's say you placed a stone over here. Now as you pull the band back, what happens? There are 2 forces acting over here. Okay, that is, this string over here, this will experience a tension force in this direction, right? This is force, let's say this is a force F1, and this string over here will experience a force in this direction, F2. Now the result of 2 different forces, as you release this object, what will be the direction in which this object will go? That will depend on the result of these 2, the resultant force acting on these 2 directions. Okay, now you can actually use parallelogram law, right? This you can actually take it as, alright, now this looks like a parallelogram, right? Now the final effect will be in this way. The final force will act in this direction. So you have one vector, F1 vector, there is another vector, F2 vector, acting on 2 different sides. Okay, according to parallelogram law of vectors, right, the resultant force will go in this direction. This resultant vector, okay, will be the force of because of F1 and F2. Okay, so that will be the resultant direction in which this object would move. Okay, so on this note, we are coming towards the end of today's class, and once again, if you have any doubts, you can ask me in the comment section and I can stay back and answer your queries, doubts. Alright, and in the next class we will see analytical method for vector additions. Alright, so now before I end the class, once again we have an ongoing batch for class 11, and this batch started only on 8th June. So any classes you have missed till now, you will be given the class recordings. You can watch the class recordings, and in Unacademy you have the advantage of every 4th class being a every 4th class being a 4th session in a plus course being a doubt clearing session. So you can ask your doubts there. Okay, and the mode of delivery is going to be in English. For physics, we meet every Tuesday, Thursday, Saturday between 5:15 to 6:15. So in a month, the minimum number of classes you will get for each of these subjects is 10. Minimum number of classes. So in a month, you're getting totally 40 classes per month. You're getting a minimum of 40 classes per month. Okay. Other than this, there will be analysis session. This is the minimum number of classes you're getting per subject. Alright, and other than this, there will be analysis session, right, and there will be doubt clearing, there will be live test series as well. Okay, and there will be analysis session for the same as well, other than these. Okay, and once again, if you're in class 11 and if you're taking a class 11 subscription for 1 year, class 12 subscription is absolutely free for you guys. Okay, so don't miss out on this opportunity, and we have only started the portions now. Alright, and you can use my code MTIS10 along with this particular class 11 subscription. Along with that, you're getting a class 12 subscription free. Along with this, if you're using my code, you will also get a 10% discount. Alright guys, so now for class 12 also we have an ongoing batch. Okay, and once again, the target of this particular Brahmastra batch is your mid-term syllabus coverage. So we would be covering all of your term 1 syllabus. Okay, so we'll be looking at the first 5 units. Now, the class 12 also, there is a course going, there is an ongoing batch. For class 12, we started a little early, simply because you will have more time for revision going forward in the year. Okay, so we in the Achievers batch, we will be covering your midterm syllabus coverage, that is your first 5 units. Okay, again the mode of delivery will be the same teachers whoever is taking these subjects will be handling class 12 also. So again for class 12 I'll be teaching, but in this case between Monday, Wednesday, Friday between 5:15 to 6:15 p.m. Okay, now we are introducing the community feature. Alright, so you do not have to miss any update from your favorite educators, right? And what you can do is you can share your feedback directly with the educators via poll feature as well. Okay, so go down to the description box. There would be the link to the class 11 community. So you can go to my community and there will be many MCQ type question asked from your unit 1. Alright, because we had just completed unit 1 on the YouTube channel, right? So you can actually go down to the community channel and you can actually look into all of those notes. Okay, now Bugs Bounty, this is in case in any of the videos if you're seeing any inappropriate content, you can actually report it and you can claim your prize. Now with this note, I'm coming towards the end of the session. If you like the class, please share it among your friends, and also don't forget to subscribe to the channel so you are always notified about the upcoming classes, and also click on the bell icon to get notified about the class timings right then and there. Okay, and thank you guys, and I'll see you guys in the next class.